So at the top of this page, I just wanted to remind you, depending on the question, you might have to worry about how you write the maximum or a minimum. I told you, sometimes they want just the x value, sometimes they want just the y value, and sometimes they want the ordered pair. For instance, again, if this were a profit function, x would be the number of units to produce, the function value would be the profit. So when they want to maximize profit, they might want to know how many units should I produce to maximize profit. That would be the x value. And what is the maximum profit? That would be the y value or the function value in that case. And sometimes they actually want the ordered pair at the point. So you have to think about the question, what do they want? Do they want the x value of the max and min? Do they want the y value of the max and min? Or do they want the ordered pair? Again, if I am to err on the side of caution, I always give the ordered pair because that gives both people their satisfaction. They know both the x value and the y value. So it says it is important to determine which of these three forms the question is asking for. The first form only gives the x value, the second form only gives the y value, the third gives the point of the graph containing both the x and y value. This is especially important when it comes to interpreting the answers of application problems. Okay, so what are we going to do? We are going to do the exact same thing that we just did for intervals of increasing and decreasing. Find those critical values, create that number line, test a point, determine where it's increasing and decreasing. But once we have done that, we can go one step further and actually determine maxes and mins as well. So let's start off with a nice trigonometric function here to get us going on the application of the first derivative test. So again, the first step is going to be find those critical values. So the critical values are where the derivative is equal to 0 or undefined. So let's find the derivative. The function is 1/2 x minus sine of x. The derivative of 1/2 x would be 1/2, and the derivative of negative sine of x would be negative cosine of x. This function is never undefined, but it is equal to 0. So let's add cosine of x to both sides. I'd have 1/2 equals cosine of x. So the question is, where does cosine of x equal 1/2? Well, we do want to note all we care about here is the interval from 0 to 2 pi. So remember, cosine of x is the x value on the unit circle. 1/2 means the x value is smaller, so we're closer to the y-axis here in both the first and the fourth quadrants. First and fourth quadrants. So here's what I'm looking at. I'm looking at this point right here and this point right here. That's when my x values are going to be 1/2, okay? And so what are those angles? Those angles are, well, it would be x equals pi over 3 for the first one. And then the next one would be 3 pi over 3, 4 pi over 3, 5 pi over 3 would be the next one. So there are my critical numbers right there. So what do I do at this point in time? Well, now what I want to do is I want to do the number line. So let's take a look at that number line. On that number line, I'm going to graph it. Now, what I want to graph it from, let me use black. When I want to graph it, I know that I need to start at 0 and go to 2 pi because that's all we care about here, right? So this is going to be with parentheses. I need to put tick marks at these places. So here I'd have something like pi over 3 right here and 5 pi over 3 right here. I don't really care about the accuracy too much in this case. But let's consider those intervals. The first interval would be 0 to pi over 3. The second interval would be pi over 3 to 5 pi over 3. The third interval would be 5 pi over 3 to 2 pi. So those are my test intervals. Again, what we care about is what is the sign of the derivative of the function. Remember, at pi over 3 it was 0, and at 5 pi over 3 the derivative was 0. At 0 and 2 pi, we don't care. We do not need to use endpoints here because it is open parentheses in the problem, so we don't need to care about what happens at 0 and at 2 pi. So step 3, we need to do that sign chart. What we need to do is take x values from each one of those intervals and plug them into the derivative. Remember, the derivative in this one was 1/2 minus cosine of x. So let's look at our values here. We need to pick a value in the first interval. So we need something between 0 and pi over 3. So I'm going to use something like, I don't know, how about pi over 4 is what I want to think about. How about between pi over 3 and 5 pi over 3, the next interval? How about pi? And then between 5 pi over 3 and 2 pi, let me think. How about, I'm going to do that one that's halfway in between the last one. So that would be what, 7 pi over 4? Not all the ones that I have to use. I can use whatever the heck I want to use. But let's go ahead and do this, okay? So let's look at the first interval, pi over 4. Plugging it into the derivative. 1/2 minus cosine of pi over 4. Well, cosine of pi over 4 is root 2 over 2. And root 2 over 2 is bigger than 1/2. So 1/2 minus root 2 over 2 would be a negative value. At pi, what is cosine of pi? Cosine of pi is -1, so I'd have 1/2 minus -1. 1/2 minus -1 would be a positive number. 7 pi over 4, again, my cosine value is root 2 over 2, and 1/2 minus root 2 over 2 would be a negative number. So what have I determined? Because at pi over 4 it was negative, the entire first interval, the derivative has to be negative. Because at pi it was positive, the entire first interval, the derivative must be positive. And because at 7 pi over 4 the derivative was negative, the derivative must be negative on that entire third interval. Now we can use step 4 is going to be us making our conclusions. Where the derivative was negative, I am decreasing. Where it was positive, I was increasing. And then again, negative, I was decreasing. Now we can use the first derivative test. Because I go from decreasing to increasing at a critical value, I know that that point has to be a minimum. And because I go from increasing to decreasing at 5 pi over 3, I know that that value must be a maximum. But remember, when I want a minimum and a maximum, I actually need to find the ordered pair, the point. So let's actually find the point here. This is going to be step 5, is finding the actual point. So I know f of pi over 3, let me use black here. F of pi over 3, putting that into the original function, would be 1/2 times pi over 3 minus cosine of pi over 3. So I'm going to put that into my calculator. I'm going to put 1/2 times pi divided by 3. Then I'm going to do minus cosine. Make sure your calculator's in radian mode of pi over 3. Close that off and let's see what I get. I'm getting approximately equal to 0.24. 0.024. And we know that that point is a minimum. So the relative minimum, or the local minimum in this case, would be the value pi over 3, 0.024. I'm not sure if they want just the x value, just the y value, so I'm going to find the actual point. Likewise, with the relative maximum, we need to plug in 5 pi over 3. So that would be 1 into the original function, 1/2 times 5 pi over 3 minus cosine of 5 pi over 3. Plug that into your calculator. Again, we're going to get an approximation here. So I'm going to do 1/2 times 5 pi over 3 minus cosine of 5 pi over 3. And I'm getting approximately 2.12 if I go to 2 decimal places. Okay? So my max is going to be an x value of 5 pi over 3 and a y value of approximately 2.12. Okay? Let's go back and let's look. When was it increasing? It's increasing wherever the derivative was positive. The derivative was positive on pi over 3 to 5 pi over 3. Where was it decreasing? It's decreasing where the derivative is negative. So that was on 2 intervals. The first interval being 0 to pi over 3. The second interval being 5 pi over 3 to 2 pi. So we have now been able to find the intervals of increasing, decreasing, maximums, and minimums.